Welcome to Unreal Gems. Up until now we have been dealing with the boring stuff, but I hope that you see that with the rigid body animation nodes you can do pretty cool stuff, like for example hair physics. So a quick recap, remember that if we wanted to simulate physics in our characters from the animation blueprint, we had two options. On one hand we had rigid body animation nodes, which remember were slower, so worse performance, but the quality of the physics simulation was better and also needed a associated physics asset. And also we had Anim Dynamics, which didn't need a physics asset, is faster, but the final quality is going to be worse. Okay, so let's start with the urban nodes, so rigid body animation nodes. Remember that we can use them to simulate simple physics in our character, like for example here, these tubes that hang from the Paragon character's head. And we are going to do it with this animation node, the rigid body node, and it is going to have an associated physics asset that is going to allow us to simulate all the components, all the rigid bodies, and get those physics simulations on those simple objects in our character. One important difference between the urban nodes and the Anim Dynamic nodes is that urban can collide with the rest of the physics assets in the level. So for example, if these tubes would collide with a, let's say, cube or another static mesh in the level that had collision, it's going to react to that, while Anim Dynamics ignores everything. So just bear in mind that for a better result, usually we use the rigid body animation node, but remember that it is costly, and if you activate those physics interactions with the rest of the level, it is going to be even worse. So for example, maybe for a mobile game, urban nodes are not the answer. I would go for Anim Dynamics or another option. Okay, so first thing, we are going to deal with the short chains, so the short hair locks from Citrine. I have already created the longest hair rigid bodies because it is a really time consuming process and the video would take like 2 hours or something like that if I would do it step by step with all the hair. So let's go ahead and start first with the easiest part, which is the shortest chains. In this case, it's going to be that bone. So we are going to use this bone as the hinge. So hair mesh 10.1 is going to be the hinge from where the other rigid bodies are going to simulate. So let's go ahead and add replace bodies. That is going to create a rigid body that we are going to set up to be the hinge. And let's go ahead and resize it a little bit and make it a lot more representative of the bone and the hair. So let's go ahead and rotate it. And this is the same process or similar as the process that we followed in the ragdoll tutorial, but it is a little different. I'm going to make it a little smaller than the hair because if not, we can have trouble with the rigid body hitting the rigid body of the head, and that can be problematic. We're going to set the mass as 100 because it is going to be the hinge, and the physics type is going to be kinematic because it is going to follow the bones. So the other rigid bodies are going to simulate from this one, so hang from this one, and that's why we do that. Let's go ahead and add another rigid body to the other bone, the hair mesh 10.2, which is going to create a constraint between the previous rigid body and this one. And now we have to again make it follow more or less the shape of the bone. As you can see, it is not perfect how it is created by Unreal, so we are going to, as always, have to resize it and and make it the correct size. Again, as always, let's do it. Let's make the constraint locked so it doesn't bother us and it does not do weird stuff. If you feel like there is too much on the screen, you can disable the bones in the character section, but let's go ahead and keep it as is because I want to compare the rigid body to the bone that it is representing. As you can see right now, the position and the shape is not correct, so that's what I'm doing. I'm rotating it and repositioning it, and more or less it is getting there. Okay, so let's now reposition the constraint so it is in the middle of the two rigid bodies, which is the correct place to be. Let's look at everything from different angles to see if everything is looking correct. It looks okay. It is in the middle of the two rigid bodies and it should be correct. Okay, so let's go ahead now and add the next rigid body, which is going to be Hermesh 10.3. Add replace bodies. That is going to add a constraint and a rigid body. And again, we are going to need to lock the constraint and also resize the rigid body and position it properly. So this is the same as always, and check out my other videos if you are having doubts, but it is going to be the same process. So let's go ahead and position it. We are going to center the camera with F on the rigid body, and now with Alt and left click, we are rotating and resizing it properly. So let's just rotate it and resize it. We are trying to mimic the shape of the hair, so that's what we are pretty much trying to do. Once we are satisfied, it doesn't need to be perfect, okay? So just bear that in mind. If we wanted a perfect result, we would probably use a convex hull or other types of primitives, but this is more than enough for this type of hair. So let's go ahead now and start dealing with the chain. We need to adjust the mass. We start with a 2 and we will go up. We are also applying linear damping and angular damping, so the simulation is smoother. And right now we are almost done with this body. Let's set the physics type to simulated. Now let's go ahead and change the mass and go to 16, which should be higher than the last bone. And let's leave the linear damping and angular damping as is because it's not the end of the chain. And now let's go ahead and set the physics type to simulated. Once we have all of this, we can go ahead and start dealing with the constraints. So let's unlock now the two swing motions in the constraint and let's deal with the limits. I'm going to set 20 degrees as the swing 1 limit and 20 as the swing 2 limit. Well, let's go ahead and make it less, make it 15, both swing limits. And again, we are going to test the rigid body as is and see what happens. So let's go ahead now and see what's going on. As you can see, the cone represents the limits that we have, and let's set the second swing limits also, again to the more or less the same. We are setting the limits to 15 and you can see the cone, the 3D cone representing those limits, and you can take a look right now at both of them. We are still not done. We are repositioning it to be better aligned with the rigid bodies so that it represents better the hinge position. And right now you can see that it is closer to the bone. We may need to readjust the rigid bodies, but we can go ahead and start testing as is the simulation and see what's going on. I'm pressing Alt-Shift-I to simulate selected. Right now we have gravity, so it is a real scenario. We can see how the hair would react in the level. As you can see, it looks like it is working okay, but we will have a small problem, which is that as you can see, when you start the simulation, the hair falls. So we will deal with that later because we want it to be static. Let's go ahead and select the full chain. If we simulate from the hinge, everything is going to fall down, no problem. You can select the second rigid body in the chain and simulate from there. And you are going to see the same problem as with the first one. The simulation looks okay when you move it, but whenever it starts, it falls down. And that's not what we want. We want the hair to keep more or less the original position and not fall down due to gravity as soon as you start simulating, because it is going to look weird. For example, if you start the game, the hair lock is going to fall as soon as you start. So let's go ahead and now debug that everything is okay and no errors are present. For that, we go to Simulate Options and No Gravity Simulation. This mode is great for checking errors because things should not move. Be careful because the first run, if you had gravity, still has gravity, so check the second run only. Things are looking okay, so let's go ahead and configure our animation blueprint to check the results in the level. Let's go ahead now, and we have a second animation blueprint for our hair, which we are going to use to animate our bones in our hair. So we share a skeleton between the character and the hair, and that way we have a cleaner animation blueprint, because to simulate the hair we only use the second animation blueprint, this one. Let's connect to the pose, the copy pose from mesh, that is going to just copy the animation from the parent. In the character blueprint you are going to see that it is a child of the skeletal mesh, and that is going to allow it to inherit the animation that the skeletal mesh is currently playing. So we have to check use attached parent, and if we have curves or custom attributes, we also need to check those. Remember to also set the root bone to copy, which is going to be root. In our case, it's the common root bone in our skeletons. So the two skeletons from the hair and from our character are going to be the same, as you can see. And then, as I mentioned before, you can go ahead and set the hair mesh, the hair skeleton, we'll see it later. But this is the basic setup that you can use in the character blueprint to have modular characters with shared skeletons and just simulate parts of them. So let's go ahead and add the rigid body node, which is going to be the physics simulation node. And we can go ahead and set the options that we are going to need to simulate the hair bones. We can override the physics asset and select the physics asset for the hair. And that is a key part. Next, we are going to set the options. First, we are going to change the simulation space to base bone space, which is less error prone. And next, we are selecting the base bone ref, which is going to be root, which is going to be the base for that space. Next, we can compile, and this would almost work, but you can adjust more settings from the simulation, like for example, the world gravity, or when we are not simulating in world space, we need to somehow pass the movement from the character to the base bone space. That's where component linear acceleration scale and velocity come in. You can control the acceleration and velocity that comes from world space into base bone space. And with that, we are going to be able to simulate however we want and not have weird behaviors. For example, we can also control the world gravity, so the gravity in our simulation. We are going to set it to -980, which is going to be 9.8, the real gravity, more or less. And again, we need to set the acceleration scale and the velocity scale. This is going to mean that, for example, the acceleration that is coming from world space is going to be more or less, depending on if we set 0, it's going to ignore it. And if we set 1, it's going to be the maximum amount of acceleration. The same goes for velocity scale. And the last component, the last option, is going to be the linear acceleration clamp. It is going to limit the maximum acceleration just to avoid errors. Let's go ahead and set 0.4 for acceleration scale, and also in velocity scale we are going to set 0.2 and in all of the axes. And with that we are almost done. Let's go ahead and clamp a little bit more. Instead of the number, let's go ahead and use 4000. This is going to limit the forces, so we have a more controlled simulation. With all of this, we are done configuring the rigid body node, and now we can go ahead and test it in game and see how Citrin is looking. Let's go ahead and simulate, and right now you can see that everything is looking good. If I jump, the hair is kind of doing some weird stuff, and you can see that it hangs a little too much. So we are going to try to fix all of those problems. As you can see, it is also like being too stiff. So as you can see, we have a couple of things that we need to dial in before we are done. So let's go ahead and go back to the physics asset and try to fix all of these problems. Let's go ahead and select the rigid body and take a look right now at the constraint options. We can go ahead and set the limits a little higher and see how it looks. It may be too much, but we can go ahead and test it out and see how it behaves, and if it behaves better or worse. Since I find the simulation a little twitchy, let's go ahead and select both rigid bodies and increase the linear damping and the angular damping, so the simulation is smoother. Next, we have the inertia tensor scale parameter, which is kind of a secret parameter that makes everything behave as if it weighted more, so more mass, but without having to change the mass. So if you turn up this number to 1.1, 1.2, 1.3, it's going to make the simulation even more controlled. So just fiddle with it and see how it looks for you. For me, it is kind of a great parameter. Let's select the constraints. And again, since I think the simulation was a little twitchy, we can also go ahead and not only in the rigid bodies damp, but also make everything more controlled in the constraints. So we can turn up the stiffness, which is going to make the hair bounce back more, and the damping, the angular damping, which is going to make the angular movement more controlled. So as you can see, we have tons of tools to control the simulation how we want. So we can go ahead and test out the new settings and see if things are looking better. Let's go ahead and turn the camera. As you can see, it's kind of weird. The stiffness is way too much, I think. So that's what is probably causing the problems with the hair being like kind of sideways. And as you can see now, the damping is too much, so the hair does not bounce at all. So we are going to need to adjust again every parameter and see what we can do with the simulation to get a more cartoony feeling and a better simulation. Let's go ahead and turn back the stiffness and the damping in the constraints because it was way too much. Let's leave the other parameters. And now let's go ahead and simulate in the viewport, in the preview. And you can see that it is looking good, but the problem is again that the starting position, as I told you before, is probably not correct. And we are also probably having trouble because the rigid bodies are way too big. They are gonna collide probably with the head and give us a lot of trouble. So we need to think about that and try to fix it. We are turning back the damping because that was not the problem. So let's go ahead and simulate again and play the game and see what's what. We still have that problem with the hair now being too twitchy and also having some weird stiffness. Let's go ahead now and go back to the editor and try to fix these problems once and for all. Okay, so here we are back again with the rigid bodies. As I mentioned before, I think it is a problem with the other rigid bodies from the head. So we are going to try to deal with this and see what's what. Let's also deal with the starting position, because right now it is not correct. So let's go ahead and select the constraint, and remember that in the manual process, when we were creating the ragdoll asset, we locked the two swing motions and dealt with them separately. So let's go ahead and do that and change the starting position holding Alt and rotating. We want it to be aligned with the bone position. So that way, when the simulation starts, it is going to be already in position and it will not drop. It will stay there and it will not give us trouble. Let's do the same thing for the second constraint. So let's go ahead and select it, turn it, holding Alt, and align it with the bone. That's going to make the simulation stay there and only move if there is upward motion, which is what we want. You can see that there is a little movement because we didn't activate the second constraint swing motion, but whenever we do it, we should see the simulation stay stable. So as you can see right now, the movement is negligible. So right now we are almost there. And as you can see, the hair does not drop anything at all. Let's go ahead and turn the no gravity simulation so you can see it. Remember, the first run doesn't work, but the second one is perfect. Hair is staying put, which is what we want. And whenever gravity comes into the equation, there is very little movement. So this is what we are looking for. And right now, remember that I mentioned that I thought the rigid bodies were way too big. So we can go ahead and also correct that mistake. We are going to get them outside of the hair because we want to protect the hair from outside sources, but we don't want it to collide with the head. And with that, we are going to get a better simulation and it is not going to collide whenever the other physics asset is present. And with that, we can go ahead and save and play and see how the simulation is looking right now. Can go ahead and turn the camera. You can see that the hair now is not doing weird things. It's staying put and it is looking really, really good. If you use show collision, you can go ahead and see how the rigid bodies are acting. Show a skeleton to see the skeleton. As you could see, we had both skeletons working together, being the same. And right now, the hair is looking really good. Maybe it could use a little damping, but for now, I'm kind of satisfied and I will work on the rest of the short chains and let you see the final result so that you can judge for yourself if you like the result or not. Okay, so here they are. I didn't want to make this video too long, so I dealt with them already myself. You can see that I created rigid bodies for all the parts of the hair that we wanted to simulate, all of the hair lockets. And as you can see, they are kind of weird and we have a ton of them. The process was almost the same for all of them and I just fine-tuned the linear damping and the limits and so on and so forth. And as you can see, the engine is working really well. You can see here the complete result. For the short chains, we will deal with the long chains later, but you can see that it is looking really good. The hair looks really bouncy. It looks really cartoony. It was the look I was going for, and I'm kind of happy with the way it turned out. We are going to be dealing with the long chains later because they are way more complicated. Well, so that's it for this video. I hope that you now have a better grasp of the basic rigid body animation node concepts, and in the next video we are going to take a look at longer chains because they are quite more complex and you are gonna need some tips and tricks to deal with them, and we'll take a look at them together. Remember, if this video has been helpful to you, go ahead, like and subscribe, and we'll see each other in the next videos. Huge shout out and thanks to all my Patreons. As you know, making these videos takes a ton of time and effort because I research in depth all of the topics that I cover. So if you want me to keep making awesome stuff, consider supporting me on Patreon.